Welcome to Brain Vision.
Okay, in this question, we're giving a market described by the following supply and demand functions, where the quantity supplied equals 2 times the price, and the quantity demanded equals 300 minus the price. The first thing that we want to figure out is the equilibrium price and quantity. Well, we know that the equilibrium price is such that quantity supplied should equal the quantity demanded at that price. So, in order to find this price, all we need to do is set quantity supplied equal to the quantity demanded, and we have those two functions here. So we'll say 2p equals 300 minus p, and then just adding p to both sides, we'll have 3p equals 300, and we'll find that the equilibrium price is 100. From this, we can also plug in the equilibrium price to either the quantity supplied or demanded to arrive at the equilibrium quantity. And I'm going to plug it into the demand function this time. So I will do 300 minus the equilibrium price of 100, and we will arrive at an equilibrium quantity of 200. And of course, you could also multiply 2 by 100 and arrive at the same equilibrium quantity. So that's part A. For part B, we're going to impose a price ceiling, which I call P max, of 90. Now recall that the equilibrium price currently is 100. We're going to impose a maximum price below equilibrium price such that you can't engage in market activity above a price of 90. And so we can tell by visual inspection alone that this is going to influence equilibrium behavior. In particular, we should end up with quantity supplied less than quantity demanded. So I'm going to plug in this price 90 to the quantity supplied. We'll just have 2 times 90 equals 180. And then I will also plug in this price of 90 to the demand function. And we'll have 300 minus 90 renders the quantity demanded to be 210. So we see the exact behavior that we expect to see. And in particular, we know that when quantity supplied is less than quantity demanded, there are more people interested in purchasing the good than that good is available. In this case, we have what's known as a shortage. And the magnitude of this shortage is just going to be our 210 minus 180. So we have a shortage of 30. Now, in part C, we're going to institute a price floor at 90. Now, when we have a price floor below equilibrium price, we know that this is going to be an ineffective price control, because what a price floor at 90 is saying is we can sell at or above this price 90, in which case the equilibrium solution is uninterrupted. So we are just going to arrive at the original price and the original quantity that we solved for in part A. Once again, because equilibrium behavior is not influenced by an ineffective price control. And then finally, in part D, we're saying instead of a price control, the government levies a tax on producers of $30. This is just going to change the supply curve in the following way. Instead of having just quantity supplied equals 2p, we now have quantity supplied equals 2 times the quantity p minus 30. Well, since this is just influencing the shape of the supply curve, we're not going to have either a shortage or a surplus. It's just going to influence the equilibrium solution. So doing the same approach that we did in part A, I'm going to set quantity supplied equal to quantity demanded to find Q star and P star. So we have 2 times the quantity. I'm just going to multiply this out here. We're going to have 2p minus 60 equals still just the original demand function, 300 minus p. And then putting the p's on this side and the integers on the other side, we're going to have 3p equals 360, which will give us that P star equals 120. And then in the exact same way as in part A, I'm just going to plug in this P star to either of the two equations. This time I'll do the supply equation. And so we'll have that Q star equals 2 times 120 minus 60. And that will give us 240 here minus 60. So we will have equilibrium quantity of 180. And this is true for both the quantity supplied and the quantity demanded.